The following video will demonstrate how to perform shape and freeform optimization using domain morphing sets. The focus of the video is to show how to create Genesis input file in GSAM, how to create shape domains and apply perturbations on the domains in Genesis Design Studio to perform shape and freeform optimization. In the current implementation of GSAM, only raw morphing set is available. Thus, I will be using GSAM only for pre-processing. Then I will create and import the Genesis input file into Design Studio for Genesis to perform shape and freeform optimization using domain morphing sets. It is assumed that the user is familiar with the Design Studio interface. Let's start with a demo problem. The objective is to minimize the mass of the connecting rod, satisfying the constraints on stress and displacement. Now open the ANSYS workbench. A static structural solution has already been set up. Now add the Genesis system into workbench simulation so that it shares the existing model information. Now open the ANSYS mechanical. As you can see, a fixed support is provided at the small end. A force of 1000 Newton is applied in the positive x direction on the big end. Now I will create Genesis input file. Click on Genesis node in the project tree and click on Write Genesis input file icon. Save the file. Now click on Design Studio icon and select Launch Design Studio for Genesis and open the Genesis input file that we just created. This will open the mesh model with applied boundary conditions in the Genesis Design Studio. Now go to Analysis tab, select Load Cases. Now check the imported load case. Next, we will perform freeform optimization to modify the shank dimensions. Now I will create 2D chord domains. Go to Design tab, select Shape domain from the drop-down list. Push the New Domain button. Make sure that New Domain's Quick Setup radio button is selected. Push Next. Select Create New Domain Group option. Push Next. Select Point by Point radio button and select the chord icon. Now click on Pick Existing Grids radio button. Select the 4 existing grids. Select the chord created and push Subdivide button to subdivide the domain into smaller domains. The first dimension is represented by the red line and the second dimension is represented by the green line. For the first dimension, enter 2. For the second dimension, enter 10. This will divide the big domain into 20 smaller chord domains. If you want non-uniform divisions of the domain, you can use the bias option. By default, its value is 1, that is, it divides the domain equally. Push Next and push Finish. You can see 20 chord domains created in the main panel. Now I will change the color of the connecting rod. Next step is to add perturbations on the corner grids of the domains. From the drop-down list, select the shape morphing sets, push the new shape set button. Make sure that domain morphing set radio button is selected. For the design variable, keep the default option. For freeform, select yes. For freeform level, keep the default selection. For maximum perturbation, enter 5. This will allow the grids to move up to 5 mm in the defined direction. Push next. Select all existing domains and push next. Now push select none button and select the 9 grids of the top domains. In the main panel on the right, you can see the number of selected grids. As I want to modify the y dimension of the shank, enter 0, -1, 0 for XYZ components of the direction. Enter the magnitude as 1. Push Add Perturbation button. Now push the Select None button to deselect the selected grids. Now select the 9 grids of the bottom domains. Change the y component of the direction to +1. Push Add Perturbation button. Now at the bottom of the main panel, you can see 18 perturbations on 18 grids. Push the Finish button. Push the Deform Mesh button. Select Oscillate Radio button. Under Deform Mesh, select the existing shape morphing set preview. You can see the possible change in the shape due to addition of the perturbations. Next, we will perform shape optimization to modify the thickness of the connecting rod. I will create another 2D chord domain. Go to Design tab. From the drop-down list, select Shape Domains. Create a new domain. Now select Drag Out Size Radio button and select the chord icon. Select Pick Points on the Work Plane Radio button. Select the YZ plane and push Relocate Origin button. Now enter -3200 for XYZ and press enter. This will move the origin at the center of the connecting rod in the YZ plane. Now draw a rectangular domain on the viewport that encloses the entire structure. Push the Finish button. Now we will add perturbations on the grids of the domains. From the drop-down list, select Shape Morphing Sets. Create the new shape set. Make sure that Domain Morphing Set Radio button is selected. For design variable, make sure that default option is selected. For Freeform, select No. Now push Next and select the thickness domain. Push Next and click on Select None button. Select the 2 grids on the top. For the XYZ components of the direction, enter 0, 0, -1. Enter magnitude as 5. Push Add Perturbation button. Now click on Select None button. Select the 2 grids on the bottom and change the Z component of the direction to +1. Push the Add Perturbation button. Verify that at the bottom of the main panel, you can see 4 perturbations on 4 grids. Push the Finish button. Now go to Post tab. Push the Deform Mesh button. Select Oscillate Radio button. Select the second shape morphing set preview. You can see the possible change in the thickness of the connecting rod. Now the next step is to create objective. Go to Design tab. From the drop-down list, select Objectives. Push the New Objective button. Make sure that mass is selected for the response type. Make sure that Minimize Radio button is selected in the Objective Definition switch. Next, from the drop-down list, select Constraints. Push the New Constraints button. Make sure that Stress Radio button is selected for the response type. For the upper bound, enter 15,000. Push Next and select all p-solids from the list. Make sure that Von Mises is selected for the options p-solid stress. Now push Next and select existing load case. Push the Finish button. Now I will create displacement constraint. Now from the main menu bar, click on Genesis and select Options. Select Analysis Control tab and push the Advanced button. Mark the checkbox for mid-side and enter 2. A value of 2 moves each mid-side node of all second-order elements to the physical midpoint of its edge, and perturbations applied to the corner nodes of elements are averaged and applied to the corresponding mid-side nodes. Now from the main menu bar, click on Genesis and select Optimize. This will take some time, so I will skip the solve time. Now we will import the post-processing files. From the Genesis console output window, click on Import Post. Import all the files. The dsg.shp is a shape change post-processing file which contains the shape changes during each optimization cycle. Now click on View Output File. Scroll down to check Design Cycle History. The total number of design cycles are 6. For the initial design cycle, the value of mass is 0.5 kgs. For the last design cycle, the value of mass is 0.29 kgs. The mass is reduced by approximately 42%, satisfying all the constraints. Now go to Post tab. Select the shape change results for the final design cycle. As you can see, the thickness of the connecting rod and width of the shank is reduced. In traditional shape optimization, all the perturbations are controlled with the same design variable. Thus, you will observe uniform shape change in the thickness of the connecting rod. With Freeform option, Genesis splits the perturbations and assigns a different design variable for each perturbation. In this case, along the shank of the connecting rod, each of these 18 perturbations is controlled by a different design variable. Therefore, along the length of the shank, you will observe a variation in the change of the width. Now under Color Mesh, select Field Counters and select the last shape change design cycle. The color bar shows the magnitude of the shape change along the connecting rod. You can animate the shape change results. Push up and select Animation. Now in the Deform Results type, select the shape change results. Select all the design cycles and push Next. You can control the speed of the animation by sliding the slider bar. This completes the demo. I hope that it has helped you to learn how to perform shape and freeform optimization using GSAM and Design Studio for Genesis. For more information, please visit our website at www.vrand.com or email us at gsam.support@vrand.com. Thanks for watching.